I want to briefly just talk about a few comments from practice test number 2. These are just some general things that I noted. This isn't meant to be a solutions guide, but just a few things that I think are important to emphasize here. So the first is for part A of question 1, a lot of people added a pushing force or a striking force going up the ramp initially. This is not the case. What we have is a quick strike, not a continuous push up the ramp. If there was a continuous push up the ramp, what would end up happening is it would never stop moving, okay? Because that initial quick push is ultimately what makes it accelerate up. Both gravity and friction are going the opposite way. So if that force continued, it would never slow down to a stop, okay? It's quickly struck, and then we're told that it has some initial velocity and slides up the ramp. There's no longer that striking force going up the ramp. Additionally, it does say this, but a few people still did this. You don't want to put components and you don't want to label, and you want to make sure you do label the forces. Some people had components on there and lost points. Some people did not label the forces. Just drawing an arrow is not sufficient. The second part, and people definitely struggled more so with this experimental or this paragraph length response one, there really needs to be a clear line of logic. So a lot of people mentioned good points and kind of danced around the answers and got some partial credit, but very few people actually got full credit here. And the main reason was this right here. You really need that clear line of logic that links the forces acting on the object to the time it takes. And the idea of it is not for you to just say, well, these are the forces, so the time is more or less, okay? The purpose of this paragraph length response is to provide a clear explanation and actually link these ideas for the reader. So if you fail to do that, you're not going to get full credit for this second part. The line of logic you really want is you want to go, and there's two paths you can take basically. You want to go from talking about the forces to what that means about the acceleration of the box up the ramp and down the ramp, to what that means about the velocity of the box up the ramp and down the ramp, and then ultimately bring that back around to time. The other option is you can use energy in this case, and maybe that's actually an easier explanation here, but if you are using that, you're going to go from energy to talking about the work done by friction to what that means about the velocity, and then ultimately to the time. And so if you don't have that full line of logic going from one idea to the next, you aren't getting full credit. Another really important thing, I didn't see a ton of this, but there still was some of this. Speeding up does not mean faster, slowing down does not mean slower. Okay, those are separate ideas. Speeding up means the velocity is increasing. Okay, slowing down means the velocity is decreasing, but it's very possible for a slowing down object to be traveling faster than a speeding up object. So that is not a valid justification, and actually it leads to the incorrect justification in this particular case. The slowing down object going up the ramp is actually moving faster than the speeding up object going down the ramp. All right. Lastly, for this one more so than the other paragraph length response one, I saw a lot of people that did a lot of equations and a lot of deriving, and that's totally okay. However, equations supplement but do not replace, all right, words. So if you're only doing equations, that is a problem. You have to have words. It's a paragraph length response. All right, let's move on to question 2. This one as a whole was actually a pretty good question, but I do want to go over a few points that were missed fairly frequently. So the first question, you have this graph here that looks something like this, where it's stiffness versus the energy loss, and the graph looks something like that, approaching some asymptote there. The question is asking why the graph won't hit the vertical axis. So the vertical axis is this axis here. So what it's saying is, why does this not continue, okay, to this point and actually touch this axis? Think about what that means, because a lot of people answered a question that it wasn't asking. Okay, the question it was asking is, why can't it hit this vertical axis? That would be a situation where the stiffness, the x value, is 0. It doesn't mean that the energy lost is 0. It's possible to hit that vertical axis and still have energy lost. That would just be the y-intercept. Okay, it's also not asking why we have an asymptote here. A lot of people talked about why this reaches an asymptote. That's not what the question is asking. The question is asking why we can't hit this vertical axis. The vertical axis would be a value of 0 on the x-axis, which means the stiffness is 0. So the question you need to answer is, why can the stiffness not be 0? For part B, you need to make sure you justify your answer. It did say that in the question, and one of the 3 points for part B was for the correct equation. 2 of the 3 were for the justification. So if all you did was derive an equation, you may have gotten the correct equation, but you only got a third of the possible points. And then 2 final things here. And these are slightly more minor things. I don't really think they cause anyone to lose points, but we want to be careful. Quadratic does not mean exponential. This is a quadratic equation. This is an exponential equation. The key difference here is in an exponential equation, all right, the variable is the exponent, hence it being exponential. In a quadratic equation, all right, the variable is what's being raised to the second power, but it's not the exponent itself. All right, so the sample equation given in this problem was a quadratic, not an exponential. And lastly, inverse is not indirect. Okay, when we have a graph like this, all right, it looks like that, which is the base equation is y equals k some constant times 1 over x, which was absolutely the equation given. That is an inverse, not an indirect. Okay, we do talk about direct, which would be y equals k times x. That is a direct relationship, but the opposite of a direct relationship is an inverse relationship, not an indirect relationship.